So this next video is from section 3.2 and it's part 5 and it's on mutual exclusive events and disjoint sets. So this is another concept that we want to get at, and it's pretty short and sweet. Once you understand the previous material, we're going to build on that by defining something using some of that previous material. In this case, we want to use that idea of and, or the intersection, in order to talk about this kind of idea of mutually exclusive sets or events or disjoint sets. So two events are mutually exclusive if the probability of A intersect B is equal to 0. So basically there is no chance that the two events can happen simultaneously. Okay? And where that comes in terms of disjoint sets is that two sets are disjoint if their intersection is empty. So if we imagine here, right, that we have two distinct groupings and there's no intersection, so there's no overlap here, they don't meet, okay, then these sets are what we call disjoint. Disjoint means separated. That's basically what it means to be separated. And so if their intersection, that is that there's no overlap between the two of them, that means that the sets are disjoint. If two sets are disjoint, then their probabilities are mutually exclusive. That's kind of the idea. I think that maybe my language is not exactly. Let's actually change this. Then the probability of their intersection is 0. And so this makes sense because if you remember how we find the probability of A intersect B is we figure out all the stuff that's in the intersection and we count it. But since there's nothing in the intersection, that there's 0 elements in the intersection, that means the probability of their intersection occurring is actually 0. So that kind of makes sense. Let's give it a little bit of an example. All right. So let's say, for example, that we want to know we want to know whether or not the probability being a registered Democrat and a registered Republican, for example. Okay. What we know is that they won't let you register as both. So you got to be one or the other. You can't actually register as both in the United States. So the group of registered Democrats and the group of registered Republicans are disjoint. So if you were to pick somebody at random, the probability of the individual being Democrat and Republican is 0. Because the two sets are disjoint, the probability of having both occur is actually 0. So this kind of works both ways. What we got here is that if we have two sets that are mutually exclusive, then they have a probability of 0. If we have two events and their intersection, right, has a probability of 0, then those two events are mutually exclusive. So this is actually a definition. It allows us to know, right, that if we have something like this, if we have that the probability of A intersect B is equal to 0, then the two events are mutually exclusive. And it also allows us to say that if two events are mutually exclusive, then their probability ends up equaling 0. And then we have the upshot to know that if the probability, right, of their intersection, A intersect B, is equal to 0, that means their intersection is empty. There's nothing in it. Okay? So all of these ideas, they all work together. You know that if you get this probability equal to 0, the intersection, then these two events, A and B, they're going to end up being disjoint, okay, and mutually exclusive. And there you go. That's the idea of mutual exclusivity. Here's the definition. You want to work with that if somebody asks you, are these two events mutually exclusive? right? But you also want to know that if I see this, that means that the two events are mutually exclusive. They can't happen at the same time. All right, that completes the lesson.